So just continuing on, we're at number 3 on page 26. We have a 1 unit slope of 1. So again, just same idea. Connecting the dots, drawing a line segment. All right, we also have a root of 2, just a single root. All right, so my roots, well, there's supposed to be 2 of them. X equals 2. But if there's 2 of them, if there's supposed to be 2 of them, and there's only one x-intercept, it must be a double root. So the corresponding factors, x minus 2 equals 0, a couple of times. My a value, 1 unit slope. And so what we'd be looking at is a function f of x would be equal to 1 times a couple of x minus 2's. So x minus 2, x minus 2. So f of x would be x squared minus 4x plus 4. There's really no correcting it when I make a little mistake like that, so I just got to undo. All right. I mean, the technique is pretty consistent, so that's a good thing. You know, it gets a little wonky when we get down to numbers 5 and 6 and so on, but let's tackle number 4 real quick. You know, scaling is still the same, but again, now we're looking at a negative 1 unit slope. All right, just be careful about the scaling. You know, every now and then it'll change up on you. If it's going by 1s or 2s versus, I'm sorry, 2s or 4s or 3s or something like that as opposed to 1s, then you might have to make an adjustment. Yeah, it's not calibrated the way I want. You see? Little reminder of what it's like to be in class. All right, a little bit better. All right, so down 1, over to the right 1 unit. All right, so my a value is going to be a negative 1. This looks like a negative 7. This looks like a negative 3. All right, so my roots, I got x equals negative 7, x equals negative 3. So, you know, you start streamlining the process. So maybe you just jump right to the factors. See, there's really no correcting it once I mess up. X plus 7 equals 0. Now, it's really not factors. It's first degree linear factors in the form of a linear equation, but that's a mouthful, so we just say factors. And function. Yeah, you need to draw a little arrow here, a little arrow there. Boop. Forgot the plus sign. Okay, so my function is going to be f of x is equal to negative 1 times x plus 7 times x plus 3. All right, so just distributing it out. And you know, sometimes you won't have to distribute it out. Sometimes factored form is fine, but you got to be prepared. All right, so we're going to have that negative 1. That's the last thing that's going to get distributed. X squared plus 10x plus 21. So negative x squared minus 10x minus 21. That's my function. All right, so, you know, it's a little bit of work, but, you know, if you get comfortable with it, you can streamline the process a little bit. Now, here, for numbers 5, 6, 7, and 8, this is like region-style questions, and incredibly annoying, because they tell us only that the vertex is a maximum or a minimum, but it says nothing about the 1 unit slope. All right, only that we know that the 1 unit slope should be positive if it's a minimum, and negative if it's a maximum, but it doesn't tell us anything about the width of the parabola. So for these kind of questions, we have to actually assume that they're all 1 unit slopes, just either positive or negative. So here is an a equals 1 case. All right, so these are my roots. So these are actually easier, I think, because you could just jump right to the function and state that f of x is going to be your a value, 1, times x, take the opposite sign, so x really minus whatever this guy is. So x minus the negative 3, so x plus 3. And then x minus the 4, that's not a highlighter, that's a pretty common error on my part. So x minus the 4. And then just distribute it out. All right. So in a case of a maximum, we're looking at an a value. These stray marks are getting to me. An a value of negative 1. And you know, I'm just going to jot these down for the remainder. So we'll have an a equals 1, a equals negative 1. This is a double root. So we're looking at f of x is equal to negative 1 times x minus 7 times x minus 7. So negative 1 times x squared minus 14x plus 49, negative x squared plus 14x minus 49. All right, and again, at any point, pause and ponder, as Khan Academy would say. Or, you know, rewind me. You know, it's one of the benefits of this platform is that, you know, you don't have to ask me to repeat something. You could just force me to repeat it. Yeah, so there's something to that. Now, number 7. A little weird problem. This one throws people for a loop very, very frequently. I don't like the looks of that a, so I'm just going to change it up a little bit. It's still, and so I'm going to take this one from the beginning. We have the roots. X equals 0 and x equals 5, which correspond to factors. Because what happens is people tend to neglect the 0. They think it doesn't play a role in it because 0, you know, 0 disappears. But it actually plays a role, as in it leads to another factor. It's easy to lose sight of what that factor is. Here, I'm just looking at the factored form being the same as the root form, whereas the other root, x equals 5, would correspond to a factor form of x minus 5 equals 0. Then when I put it in function form, it all comes together. So I'm taking this guy, and this guy, and that guy, putting them all together, and I'm looking at 1 times x minus 5. So once you get over that mental hurdle early on, it's actually pretty easy because it's just distributing one term, because the 1 is really kind of irrelevant. It's just the x getting distributed to each term in the second binomial. All right, so once you do the mental gymnastics early on, it gets a lot easier. Same idea with that a equals negative 1. I just didn't like the way it ended up looking. inconsistent. All right, so here we can kind of jump to it a little bit. So we would be saying that the roots, again, roots x equals 1/2, x equals 6, but then that would be x minus 1/2 equals 0, x minus 6 equals 0. But then just to clean it up a little bit, it's a nice idea to multiply by 2, and that's only because there's a fraction, all right? So when you do that, you get 2x minus 1 equals 0, all right? So then when we go to function form, I have my negative a value. Now I have a 2x minus 1. Instead of having to work with a fraction, I'm working with an equivalent equation, just a little bit nicer. And x minus 6. Still have to distribute. So 2x squared minus 12x minus 1x, so minus 13x plus 6. And then we have that negative 1 that's got to go through the whole shabiggity bangity boom here. And we'd be looking at f of x is equal to negative 2x squared plus 13x minus 6. And there it is.